Welcome back. I am using the 8.1.3 student handout. It's a link on Monday's assignment. And so if you guys can just make sure you have that printed, we're going to go ahead and go through this together. So the first section is just solving each equation for x and then checking your solution. So for a, we want to isolate x, so we're going to go ahead and add 10 to both sides. So we get 2x equals 10, and in order to get x by itself, we divide by 2, so x equals 5. All right, next one's a little bit easier. To get x by itself, we want to undo adding, which would just be subtracting. So x equals -6. On this one, you actually are going to set both of them equal to 0 separately. And so on this one, we just solved it, so we should know that it's x equals -6. And again, we should know, because we also just solved this, that it's x equal to 5. And remember to check that these are right. You can always plug them back into the original equation. All right, looking at this one, we can subtract 1, so we get 4x equals -1. Divide by 4, so x equals -1 over 4. And on this one, we are just going to add 8 to both sides, and so we get x equals 8. And once again, what we're going to do is set each of these factors equal to 0 and solve them separately. And luckily, we actually just solved them, so we should know that we are going to already have the answers. So x equals -1/4 and x equals 8. All right, you guys, so now we're going to go ahead and move to special cases. So for this, we are going to factor, but we have a term that is missing. So for example, when we look at a, we know that the trinomial is supposed to be in the form ax squared plus bx plus c. So looking at a, we have our ax squared, we have our c, but we're missing our b. So I'm going to go ahead and do that on the side here. So if we were to put what we have in our box, so in the first box, we would place 9x squared. In the last box, we would place -4. So we would get -36x squared. All right, so in our diamond, at the top would be -36x squared for our product. And then since we have no b term, it would just be 0. So that means we need two terms that multiply to -36x squared but add to 0. And it will be 6x and -6x. So we're going to go ahead and place those in the boxes. And then just like you watched in the tutorial, you find the GCF of each column or row. So 9x squared and -6x would be 3x. And 3x times 3x is 9x squared. 3x times 2 is 6x. 3x times -2 would be -6x. So our factors are 3x plus 2 and 3x minus 2. And those look like difference of squares, right? They're the same terms, but they have a plus and a minus sign. Now this next one, we're missing our c term, which means that we want to look at both terms and see, can we factor out a GCF? So what is the greatest common factor of 12x squared and -16x? And we can see that we can take out a 4x. So if we take out a 4x, we would have 3x minus 4 left. So that one actually just looks like that. All right, this next one is a little weird. It's just out of order. So I'm going to put it in standard form, 8k squared minus 10k plus 3. So we'll make our box. And now it looks like all that was wrong with this trinomial was that it was actually just out of order. So 8k squared goes in the first box. 3 goes in the second box, or the last box. So at the top, we would have 24k squared because that's the product of the diagonal. and the bottom would be negative 10k, because that is our middle term. So we need two numbers that multiply to 24, but add to negative 10. This one's a bit tricky, and it ends up being negative 4 and negative 6. So negative 4 times negative 6 turns to a positive 24, and negative 4 minus 6 will add to negative 10. So remember, at any time, please pause the video so you can catch up. All right, so the GCF of 8k squared and negative 6k would be 2k. And then 2k times 4k is 8k squared. 4k times negative 1 would be negative 4k. And 2k times negative 6k would be negative 3. And then we can check it by saying negative 1 times negative 3 is 3. So our factors for that particular problem is not 2x, it's going to be 2k minus 1 and 4k minus 3. All right, our last one kind of looks like B, where it is not in order and there's only two terms. So we have negative 100m plus 40. So since it's only two terms and we can actually take out a GCF, unlike A, it was two terms, but there wasn't a GCF that we could factor out. In this case, we can, and because that first term is negative, we want to take out a negative. So the biggest number that goes into both would be negative 20, and so this would turn into a 5m minus 2. All right, so now we're going to go ahead and look at this trinomial. So use a generic rectangle and diamond problem to factor this expression, and then we want to compare answers. So we're going to kind of look at a couple different options here. So I'm going to go ahead and make my rectangle. 4x squared will go in the first box, and then negative 6 goes in the last box. And then we can make our diamond. So I know the product would be negative 24x squared. And I used k again. All right. And then the sum will be negative 10x. So I want to think what two numbers would work for that. And the options would be negative 12x and 2x. So negative 12 times 2 would be negative 24, and negative 12 plus 2 would give us that. So negative 12x and 2x. All right, so now we're going to go ahead and find the GCF of 4x squared and 2x, which would give us 2x. And 2x times what is 4x squared? 2x. 2x times what is negative 12x? Negative 6. And 2x times what would give us 2x? And that would be 1. So the factors that we just got would be 2x plus 1 and 2x minus 6. But let's see, because I was looking at that and I feel like we could have gotten different answers. So I'm going to go ahead and recreate my box and put the same things in all the boxes. So what if we found the GCF of 4x squared and negative 12x? Well, in that case, I would have gotten 4x. 4x times what is x squared? X. 4x times what is negative 12x? Negative 3. X times what is 2x? 2. And negative 3 times 2 is negative 6. So what's happening here is that we're actually getting two different answers. So we got 2x plus 1, 2x minus 6, and then we got 4x plus 2x minus 3, but they're both actually correct. So we're going to kind of talk about that in the next video.